Hey guys, welcome back to session 5 of Introduction to Linux OS. My name is Kevin Nowens and I'm super happy to have you back with me here today. Today we're going to be going over the Linux file system, okay? So in session 4 we covered the UNIX process model, process states, and monitoring and controlling processes. Today we have quite a bit to cover, so we're going to go through it as best we can and we'll take some breaks and show you some examples of things that we're talking about. But we're going to be going over the file system organization, file types, file and directory naming rules and conventions, commands for navigating the file system, introduction to inodes, ownership, permissions, and dates, manipulating files and links, determining disk usage, as well as other file system utilities. So starting off here, let's go ahead and cover the file system hierarchy here a little bit again. You'll kind of remember this picture from the last session. So at the very top here, we're going to have our root. Remember, don't get this confused with the root user. This simply just means that this is the beginning of the file system. And underneath that, we can have a lot of other files and directories here. So we can have bin, opt, boot, root, dev, sbin, and others. And below that, we can have even more directories and files here. sbin, lib, include, bin, cache, log, and so on. So if we were to write this out, let's say we wanted to do the beginning of the file system and boot and then bin. We would do /boot /bin/. Okay? So actually let me write that out for you here on our terminal. So if I wanted to go to something like that, I would do cd space /bin and then let's do like lib. Okay, it would be written out like that. Okay, and now this is just an example. In this case, this doesn't actually exist on this system, so it's going to tell you no such file or directory, but that's how it would be written out. Okay, so on a Linux file system, a file system is a logical collection of files on a partition or disk. A partition is a container for information and can span an entire hard drive if desired. Your hard drive can have various partitions which usually contain only one file system, such as one file system containing the /file system or another containing the /home file system. Okay? Now this is really helpful because you can kind of separate everything and they don't have to rely on one another. One file system per partition allows for the logical maintenance and management of differing file systems. Okay, this is actually pretty common practice on Linux file systems, is to actually separate them into their own partitions. So if I actually bring up our machine here again and I run this command, don't worry too much about this command, we're going to go over it a little bit later. If I run the df space -h, you're going to see all these different file systems here and they can be mounted on different points. Okay, so these all can have their own partitions here and they're all separate from one another. So a Unix file system is a collection of files and directories that has the following properties. First, it has a root directory, or / that contains other files and directories, and then each file or directory is uniquely identified by its name. The directory in which it resides and a unique identifier are typically called an inode. By convention, the root directory has an inode number of 2, and the lost and found directory has an inode number of 3. Inode numbers 0 and 1 are not used. File inode numbers can be seen by specifying the -i option to the ls command. So let's go ahead and check that out here. So if I do an ls space -i, you'll see here that we have these particular directories, and it's going to list their inodes next to them. Okay, so these are all the inodes for these directories. So it is a self-contained, and there are no dependencies between one file system and another. Okay, so all this means is, like I said earlier, when you partition all these file systems into separate places, you keep them separate from one another, and this allows for management of them to become much easier. It also allows the file systems to be dependent on one another, meaning that if something goes wrong on one, it's not going to affect your other file systems. And this is a very smart thing to do, so that if something crashes, it doesn't affect the whole system. So file system organization here, directory and description. So a slash, as we've talked about, this is the root directory, which should contain only the directories needed at the top level of the file structure. Slash bin, this is where the executable files are located. These files are available to all users. And then we have slash dev, D-E-V. These are device drivers. And then we have slash etc or etc. You're going to hear people commonly refer to that as slash etc. This one contains a lot of things in it, and this is where a lot of things are going to be done as a system administrator. So this will contain supervisor directory commands, configuration files, disk configuration files, valid user lists, groups, Ethernet, hosts, and where to send critical messages, as well as a lot of other things. And then we also have some other important files here. So the first one's going to be slash etc or slash xt and slash password. Okay. So this stores user information like username, UID, home directory, and shell, etc. So let me go ahead and open up our VirtualBox here. Let me show you what's in that file. And it's important to know what's actually in all these files, because they do contain useful info. Okay, so there's a lot on the screen. Let's just go over the first part here, or maybe just one of these here. Okay. So let's focus on this guy here, the USM BMUX. Okay. So in this first field here, this is going to be the user. Okay. Second field here, where you see this X, that's a placeholder for the password. This third field is going to be the user ID. Fourth is going to be the group ID. Fifth is going to be the comment field, so you can leave a comment in there, maybe describing what it is. The next field is going to be the home directory of this user. And lastly, this is going to be the shell of the user. Okay. In this case, you see a slash usr slash sbin slash no login. What this means is that this one in particular actually has no shell, and a shell is just the terminal. Okay. Typically, when you see this means that this user is actually not a real user, and instead it's a system user, meaning that something on the system uses this ID to do things on the system. Okay. This isn't an actual user that logs in. Okay. Go back to our PowerPoint here. Next one's going to be slash etc slash shadow. So this is actually where user passwords are stored. So we saw in that etc password file that it was just an X where the password should be. Well, in this etc slash shadow file, this is where the passwords are actually stored. However, they're going to be encrypted. And in there, you're going to see that the first field is the username. Second is the actual password, but encrypted form. Third is going to be the last changed. Fourth is minimum days, meaning how many days do you have to have this password. Next is going to be max days, meaning for how long can that password actually be set before you have to change it. The following field is going to be warned days, meaning how many days can the password be expired before you get warnings and you have to change it. The next field is inactive days, how many days the password can be inactive. The next field is going to be expiry days, how many days the password's been expired. And then finally, the last field is going to be reserved for future. Let's check that file out real quick. So we're going to do cat. Remember, cat is how you look what's inside files. And we'll do slash etc slash shadow. And shadow, of course, is kind of mysterious. You know, it's where we store our passwords. So you see it says permission denied. So in this case, I actually need to elevate my privileges. So I do sudo. And then I'll do cat slash etc slash shadow. This is important. This is a good security feature, so not anyone can just look at this file. It's going to ask me for my password. And now we can actually see what's in this file here. Okay, so you'll see in this file you'll have that little star sign, and that's where the password's being stored at. In this case, all of these are system users, and so we don't actually have a password. But if you go all the way down, you can see here, you see Kevin, that's my actual user. And then you see this huge line of numbers and symbols. Okay, that's the password. It's just an encrypted form, so we can't actually see the password. You need to run an algorithm to unencrypt it to actually see my password. But this does tell me that I do have a password in there. And all these other users you see here are all system users, and they don't have a password. So next file we're going to look at is etc group. This is where it stores group information like group name, group ID, and other information. So cat that file real quick, cat slash etc slash group. And you see we just have some groups here. Input, render, syslog. These are all groups on the system. Next we have etc gshadow, and as you can imagine, that's going to store the passwords for the groups. Okay. And then next we have etc password, and then we have a small little dash next to that. Okay. Let me see if I can zoom in on that for you. Oops, too much. There we go. Okay. So you can see there we have a small slash or dash, a small dash next to that etc password. This is going to be a backup of the etc password file. Same with this next one here, etc shadow dash. That's going to be a backup of the file. Okay, and that last one there, oops, sorry, we skipped a few. So we have etc default user add. So whenever a user created, the user's default settings are taken from this file. And then we also have etc/login/defs or defaults. This is the user's login default settings information whenever they are created and logging in. Okay, and then that last one is going to be /etc/skel, SKEL. So this stores users all the user's environmental variable files, and they're copied from this directory to a user's home directory. So when a user is created, the contents in etc/skel are sent to this other user, and that creates a home directory for them. Okay, I'm going to show you the login defaults here, just so you can kind of see what's in there. So I'm going to cat the file /etc/login defaults. Okay, and we can see some default settings here. In this case, there's not a lot going on in here, just because by default there isn't much set. I could set some settings in here though, and this would create the defaults for the user. So let's talk about file types. When navigating the Linux file system, you are sure to encounter different file types. The most used and obvious file types are regular files and directories. However, the Linux operating system has more to offer in terms of file types, as it also includes another 5 file types. Okay, so in here we're kind of looking at the output of ls-l, or long listing, which I explained in a previous video. I'm going to explain again here to touch on the topic. So I'm going to do a ls-l. You can see here we have several fields, the first of which is going to be file type. Okay, so we see D here. That means it's a directory. Okay, and we see all these here are directories, except for test. You notice test does not have anything there, it's just a dash there, which means it's just a normal file. Okay, and in this next column, we see different permissions here. Okay, the R stands for read, the W for write, and X for execute. Okay, you're going to notice 9 spots here. I can highlight it all. You're going to notice 9 spots here. Okay, so this is going to stand for user, group, and other. So in this case, the first 3 we see are all marked here: read, write, execute. This means the user has read, write, and execute privileges. The next 3, we only see R and X. You'll see a dash in the middle. Whenever you see a dash, that means that that permission is not set. So in this case, the group only has read and execute permissions. And then we'll notice the same for other. In this case, other only has read and execute permissions. In this next column, this just tells you how many hard links are set to this file. And then we see here the user owner of this file, which is Kevin, meaning the user owner Kevin can read, write, execute anything on this directory. Then we also have group. This means anyone in the group Kevin will have read and execute privileges on the desktop directory. Okay? And now other would mean anyone outside of these 2 specified, user and group, would be other. In this next column, we have the size of the file, which is displayed in bytes. And then the following column we have when it was last modified, and in the last column we have the directory itself. Alright, so we've seen how to kind of navigate the file system. Let's go ahead and talk about how the file system and directory are named. So all files are case sensitive. So file name of vivek lowercase .txt, capital V vivek.txt, and all capital vivek.txt are all actually 3 different files. You can use upper and lowercase letters and numbers and dots and underscore symbols to actually name a file. In short, file names may contain any character except the / character, okay? Because this is reserved as the separator between files and directories in the path name. You cannot use the null character. Most modern Linux and UNIX limit file names to just 255 characters or 255 bytes. However, some older versions of Unix systems limit file names to just 14 characters only. A file name must be unique inside its directory. For example, inside a /home/vivek directory, you cannot create a demo.txt file and demo.txt directory name. Okay, so you can't have demo.txt and demo.txt directory in the same directory. However, other directories may have files with the same names. For example, you can create demo.txt directory in /temp. So I can have demo.txt in /temp here, and I can also have it in /home/vivek, okay, because those are different directories. So let's go over some simple commands here for navigating the file system. You've seen me do these a number of times. First one's cd, or change directory. This is used to navigate the files in different working directories. We also have ls command, which can be used to view the file system in the present working directory. We have ls -alh command, and this can be used to view the information of files in the present working directory. And we can also use the du command to check file size and also use it to check the size of multiple files at the same time. So let's go ahead and go over those real quick. So let's go ahead and list. Actually, let's go ahead and check out where I'm at right now. And if you guys remember, how we check our current directory is pwd, print working directory. So I'm in /home/Kevin. Let's go ahead and see what's contained in /home/Kevin. So I'll do ls list, and you'll see I have all these different directories here as well as one file, test. Okay. Let's go ahead and change one of these directories. I'm going to do cd, and I want to go to desktop, so I have to do capital D ESKTOP, and I'll switch that directory. Now if I want to go back, I want to do cd ... and I'll actually go back one directory. Okay. Now remember, it's case sensitive, so if I were to do lowercase d, it's going to say, hey, I'm not too sure what that is. I don't know that it exists. And that's because we did it as lowercase, so I need to make it uppercase, okay? So now you'll see here, I'll do my pwd. So I went from /home/Kevin. I cd'd to desktop here. I did that here. And then now I'm in home, Kevin, desktop. And you'll see here I'll do an ls, there's nothing in here. So let's go ahead and go all the way to that. So if you do cd command without any flag or option on it, it's actually just going to take you all the way back to the root directory of the system, which in this case is home/Kevin. Okay. Go ahead and clear my screen here. So the next command we saw was ls, but it had some flags on it. It had -a, l, h. Okay. So now we see you get a lot of info here. So what these flags mean, -a is all, L is long listing, as you remember from our previous sessions, and H is human readable. So what -a does, or all, is it actually shows you hidden files here. And how you know a file is hidden is by this little period placed in front of it, okay? So you can see all these here are hidden files. This would not show up if we didn't have that -a flag on it. -h makes it human readable. So you'll see here our size now is in kilobytes, which is a little bit more user-friendly as opposed to bytes, okay? So let's run those commands without those flags on it. So if I do a ls-lh, you'll notice those hidden files are gone. However, you'll see this is still human readable because it's got the size in kilobytes. So let's do an ls-l, and now you'll see that the size went back to bytes here. Okay. Also keep in mind, or be aware, that I don't necessarily have to put all those flags right next together. I can do -a, -l, -h. That's going to give me the same info. or I can also run them all together, LAH. And I get the same info again. Okay, so you can separate these or you can keep them as one, but the system knows by putting that dash in front of it that these are all different flags. Okay, it knows that this isn't a word you're putting in. So I could do ls dash dash help, and now the system recognizes that this is an actual word or command that I'm putting in. Okay, and you'll see it lists some help for the command ls. Alright, so let's go ahead and introduce you to inodes. A directory is really just a file, okay? It's a special file, though, with special rules. You can't just type cp/dev/null/directory to erase it, okay? It's got special bits to make sure a mere mortal can't mess it up, okay? So someone like me or you can't just go in and start messing up files or directories. Because if a file system gets corrupted, then you can say goodbye to your data, alright? So if the whole file system gets taken down, then everything in it, contained in it, is going to go away. So it's good that directories have special rules for it. And this is also why we separate the file systems, so that if one goes, they don't all go. So a Unix file is stored in two different parts of the disk, the data blocks and the inodes. The data blocks contains the contents of the file. The information about the file is stored elsewhere in the inode. Okay? Both the inodes and data blocks are stored in a file system, which is how a disk partition is organized, but these inodes are strange and confusing. We will use the ls-i command to check the inode of file and df-i to see the inode of partition. Okay? Also, something else to mention is that when we do the mv command, what we're actually doing is we're changing the inode of that file. Okay? So we're telling the system, hey, we're moving it to a different inode, and now it's being stored somewhere else on the system. So that's what that mv or move command is actually doing. It's changing the inode of that information. Alright, let's go ahead and move on to ownership, permissions, and dates. So we're going to spend a good amount of time on this because this is actually really important info for the Linux system. This is how it stays secure, and this is how a lot of things are run on the system. So file ownership is an important component of the Unix system that provides a secure method for storing files. Every file in Unix has the following attributes. It has an owner permission, or owner of the file, and this determines what actions the owner of the file can perform on the file. It also has group permissions. The group's permissions determine what actions a user, who is a member of the group that file belongs to, can perform on the file. We also have other or world permissions, meaning everyone else besides the owner and group. And the permissions for others indicate what actions all other users can perform on this file that are not part of the owner or group. So when we run the ls-l command, it displays various information related to the file, such as the permissions of the file. So let's go ahead and look at that real quick. So we'll do an ls-l. And as I explained just a bit ago, in this first column, we see the permissions here. Okay? So that's how we can see the permissions on these files. So the permissions are broken up into groups of threes, and each position in the group denotes a specific permission in this order: read, or R, write, or W, or execute, X. The first three characters, 2 through 4, represent the permission for the file's owner. For example, read, write, execute, read, represents that the owner has read, write, and execute permissions. Okay, so those first three there. Oops, too much. Let's see if I can highlight it for you. Not quite, but I'll show you on the terminal here. But you see those first three there are for the user. Okay. The second group of three characters, 5 through 7, consists of the permissions for the group of which the file belongs. For example, we have read, write, execute, and read. This represents that the group has read and execute permissions. So you see the dash in the middle. This means that write is not set for the group. The last group of 3 characters, 8 through 10, represents the permissions for everyone else. For example, using that same set of permissions, we see this last group of 3 here. We see an R, which means read. We see a dash and another dash. This represents that there is read-only permissions. Okay, so let's check that out on our system here. So we'll see for the test file here, that in those first 3, we have read, write, execute. Okay, so that means user has read, write, and execute permissions. The next 3 has read and write only, and then the last 3 is just read. Okay, so user has read, write, execute. Group has read and write, and then other has read only. Okay, so the user Kevin has read, write, and execute permissions, and the group here, which is also Kevin, has read and write permissions. So, to change the permissions, or to change the file directory permissions, use the chmod or chmod command. There are 2 ways to use chmod, the symbolic mode or the absolute mode. Let's take a look at the symbolic mode here. So the easiest way for a beginner to modify the file directory permissions is to use the symbolic mode. With symbolic permissions, you can add, delete, or specify the permission set you want by using the operators in the following table. Okay. The first one we have is plus sign. This adds the designated permissions to a file directory. The next we have is a minus sign, which is remove the designated permissions from a file directory. And finally we have the equal sign, which sets the designated permissions. So an example of how to use that, we have test file. So running ls-l on test file shows that the file's permissions are as follows. So we have ls-l test file, and then you can see there it's read, write, execute, and then read. So using that chmod command, we can use various different ways to change the permissions on it. Okay. So this first one here, we see chmod space O, which is other, plus write and execute. And when we run ls-l again, that gives other the write and execute permissions now. Okay. So you see above it was read only, and now it's write and execute. We can also take away permissions. So chmod space user, U, so U stands for user, minus, so take away, execute permissions. So if you run ls-l on test file, you will see now that execute has been taken away from the user. So before up here we see user had execute, and now execute's taken away. And then we can also use the equal sign. So chmod space G, which stands for group, which is going to be the middle 3, equals read and execute. Okay? So we run an ls-l on test file, and now we see the group has read and execute permissions. Okay? So this, using the equal sign, will actually set the permissions. Even if it had write permissions before, it's just going to set it to exactly what you state. Okay? And you can actually combine these commands on a single line. So we can do chmod space other O plus WX, comma, user U minus X, comma, group space equals space read and execute. Okay? So what that's going to do on other, it's going to add write and execute. On user, it's going to take away execute. And on group, it's going to add read and execute. Okay? So let's go ahead and demo this real quick for you guys. A little bit easier to understand on the terminal, I think. So let's go ahead and do an ls just to see what I had. So I have that test file, and that's what we're going to be using to change permissions on. Okay? So let's do an ls-l to look at the permissions here. And you'll see this test file has read, write, execute for user. It has read and write for group. And it has read only for other. Okay. Let's go ahead and do chmod. And let's do other, O, plus, so add. And let's add write to it. Okay. Or let's go ahead and add write and execute, so we can follow the example in the PowerPoint. And then you have to specify the file you're doing it to. Okay? Now let's do an ls-l. And now you'll see that on other, the test file now has write and execute privileges. Okay? Whereas before, it only had write privileges. Okay? Let's go ahead and clear the screen. Now, we're going to do chmod. We're going to do user minus, which means take away, x execute permissions on that test file. Okay? Actually, let's show the test file, ls-l. So you can see right now user has read, write, and execute permissions. So we're going to do chmod user u minus x execute test. Okay. Do ls-l. And now we can see that the user had execute permissions taken away. Let's go ahead and clear screen. Now on the last one here, we do chmod, or let's do our ls-l first so we can check the permissions. We're going to do chmod. We're going to do group equals read and execute on the test file. Okay. So before we do that, we look here, group, which is going to be the second set of 3 here, has read and write only. Okay. We're going to set it equal to read and execute. Let's hit enter. Oh, interesting. chmod group, invalid mode G. Let's get rid of those spaces. Let's see if that'll. Oh, forgot to put the file. That's why. Okay. Chmod group equals read and execute. There we go. There shouldn't be a space in between the G and read and execute. Okay, so now we'll check it out. And we'll see group now has read and execute permissions. Okay. So let's go back to our PowerPoint. So I want you guys to look at that equal sign example in there. So that space actually shouldn't be in there. It should be G equals Rx, no space in between those. Okay. Now in this last example, it showed you how you can combine multiple ones. Let's go ahead and do that real quick. Let's clear our screen. So we're going to do chmod. We're going to do O plus, so add, write and execute, comma, U, user, minus, take away, X, execute permissions, comma, we're going to do group equals read, execute. We're going to do that on the test file. Okay? We'll do ls-l. And we'll see here, so we added write and execute for other. Okay. We took away execute for user. So that's that first one, so no execute on here. And then we made group equals to read and execute. Okay, so second one here, read and execute. All right. Let's go back to our PowerPoint. So changing owners and groups is different than changing permissions. So while creating an account on Unix, it assigns an owner ID and a group ID to each user. All the permissions mentioned above are also based on the owner and groups. Okay? So 2 commands are available to change the owner and the group of files. chown or chown. The chown command stands for change owner and is used to change the owner of a file. And then we also have chgrp or change group. The change group command stands for change group and is used to change the group of a file. So we can see in our example here, the change own command change the ownership of file, and the basic syntax is as follows. So chown space the user that we're going to be changing ownership for, and the file itself. Okay, so file list will have its owner changed to user. Okay? Its user will be changed to user. The value of the user can be either the name of the user on the system or the user ID of a user on the system. Change group follows a pretty much similar syntax. So we do change group space, the group you want to change it to, and then the file you're changing. Okay? So in this example, file list will have its group owner changed to group. The value of the group can be the name of the group or on the system, or the group ID of a group on the system. Okay? So let's go ahead and show you that real quick. Clear my screen here. We're going to be using test file again as our example, so we'll do -l. You'll see on test file here, the user owner is Kevin, and the group owner is also Kevin. So let's do change own, CHOWN, and I'm changing it. We're going to change it to root, and the file I'm changing is test. Aha, so you see it says operation not permitted. Okay, so I need to elevate my privileges. So I'm going to do sudo. I'm going to run that same command, okay? It's going to ask for my password to elevate my privileges to root. Okay, so now if I do an ls-l, you'll see that the user owner of test was changed to root here. Okay? So let's go ahead and clear our screen. Do an ls-l. You see the user owner is root. Let's go ahead and change the group now. Change group. The group you want to change it to, which is root, and then the file you want to change. And again, I didn't do sudo, okay? So I have to do sudo to elevate my privileges because only root can do this action. And then I'll do root. Let me put change group first. Root test. Okay. And that password I was putting in when I did sudo, guys, is just the password you use to log in your machine. So I'll do an ls-l. And you'll see here that test is now owned by group root. Okay. Let's go ahead and change those back real quick. So sudo change own. I want to change it back to Kevin. I'm changing the file test. Okay. Now you'll notice this time it didn't ask me for my password for sudo, and that's because I've put it in a few times now, so the system just recognizes that I do have those privileges. So we're going to do that again. I'm going to press up, and I'm just going to actually change own to change group, so I don't have to type all that in again. Okay. I'm going to do an ls-l, and you'll see here that the user and group was changed back to Kevin. Okay. It's not too difficult. All right. Now the other way to change permissions is actually the symbolic way. Okay. So this can be a little tricky, so I suggest writing this down or maybe looking up a little bit more about how these permissions are written. So each read, write, and execute has values assigned to them. Okay. So the value for read is 4, write is 2, and execute is 1. Okay, and null is 0. So the total value for read, write, and execute permissions is 7. So as an example here, if I were to do the change mod command, I would do chmod space 774, and I'm changing file 1. Okay, so what this says is the user here, the first set here, is going to have read, write, and execute. So 4 plus 2 plus 1. All right, I'm turning on all permissions for that user. Okay, for the second one here, I'm also doing 7. So 4, which is read, plus 2, which is write, plus 1 is execute, and that equals 7. Okay, and that's for the group. And then for other, I'm only doing 4. So since the value is 4, that equals read. So I'd be changing other to just read. So another example here. Chmod 4 plus 2 would equal 6. So for the user, I'm granting read and write privileges. For the group, I'm granting read and write privileges because 4 plus 2 is 6. And then for other, I'm putting in 0. Okay? So 0 means I give them no permissions. Okay. So for file 2, that's going to change the permissions to read write, and none. Okay. Let me go ahead and show you that on the virtual box here. Let me clear my screen. So we're going to be working with test file again, or just test, sorry, the file named test. I'm going to do chmod. I'm going to do 777 test. And then when I hit enter, it's going to change all these permissions here to read, write, execute, read, write, execute, read, write, execute. And as you see there, it in fact did change all those to read, write, execute, read, write, execute, read, write, execute. Okay. Let me clear my screen. So when we're changing those permissions using this way, it has to add up to something. I can't just put a 3, okay? I can't put like 3, 3, 3, okay? Because that doesn't make sense. Read is 4, write is 2, and execute is 1. Actually, that does make sense. Sorry. Simple math, simple math. 2 plus 1 would equal 3, okay? But I can't have a number like 9, okay? Because no combination of read, write, and execute would equal 9. I can't do that. See, invalid mode, 999. Doesn't make sense, okay? I could actually do 333. Okay? And what that would do is it would give write and execute permissions, okay? Because remember, read equals 4. Write is 2. Actually, let me go back to PowerPoint here, show you. So read is 4, write is 2, and execute is 1, okay? The only way we're going to add up to 3 is if we do 2 plus 1, meaning write and execute. Okay? But there's no way I could ever make these 3 equal 9. Okay, so it has to equal a combination of these numbers. So if I do that, I do an ls-l, or let me run that command first, and then ls-l. You'll see now that test just has write execute, and write execute for user, group, and other. Okay? Alright guys, we are on the home stretch here. We're almost done with this session. We're going to look at manipulating files and links here. So to work with files and links, we use the following commands, which we've seen a couple of times now. CP, which is copy files and directories. MV, which is move or rename files and directories. RM, which is remove files and directories. And mkdir, make directory, which is create directories. These 4 commands are among the most frequently used Linux commands. They are the basic commands for manipulating both files and directories, okay? And we've demoed those a couple times now, so you should be fairly familiar with how to actually use these commands now. A couple other commands we can use on our system is the df command, which stands for disk free. So this shows the amount of disk space used and available on the Linux file system. We also have the du command, which stands for disk usage. So this displays the amount of disk space used by specified files and for each directory, okay? So this can be a little confusing at first. So think as df is like a whole picture of the system, okay? It's going to list all file systems and how much space is available on them. Du is going to be like a specific snapshot of a certain directory and what's being used on it, okay? So let's go ahead and take a look at that now. So if I do df command, it's going to show you all my file systems here on this left side. And it's going to show you how much available space is on it. Okay, so you see all these 0%, 1%, and all these are actually completely full. But we don't have to worry about that. Let's take a look at slash here. Okay, it's 62% used. Alright, let's go ahead and cd to slash. Okay, and we're going to do pwd. It's going to say we're at slash. So now we're going to run the du command. Okay. So du, and we're going to specify, well actually we don't need to specify slash since we're right here. So we're just going to do du. Now, you're going to see a ton of stuff be outputted, okay? So it's actually showing us every single file in slash and what's being used by it, okay? I don't actually want to see all these, so what I'm going to do is I'm going to click Control-C, and if you guys remember, That's the signal interrupt command. Oh, well, it actually finished. But if I would have clicked Control-C, it would have stopped that command, right? Obviously, I'm not going to look through all of this to see what's taking up the space, okay? But that does show every file under slash and what's actually using the space, okay? So let me clear my screen here. We can also put a -H flag on the df command. This can be human readable, okay? So now it actually shows it to me in megabytes and gigabytes, which is a little bit easier to understand instead of kilobytes and bytes, okay? I can do the same with du. I can do du-h. And again, it's going to run all through that, and it's going to put it in gigabytes and megabytes. I'm going to hit Control-C. I'm going to stop it. So stop that command. I don't need to see all that. So that's the difference between df and dh. df shows you a grand picture of the whole system. Du shows a snapshot of a specific directory you're wanting to look at. So a file system is a way in which files are named, stored, retrieved, as well as updated on a storage disk or partition. It determines the way files are organized on the disk. A file system is divided into two segments called user data and metadata. User data is typically local data that individuals need to complete to specify their tasks. So this data is kept in the /home file system, where file systems are created specifically for user data. Metadata is just data that provides information about other data, okay? So that's typically the difference between these two. So metadata can be file name, time it was created, modified time, its size and location in the directory, hierarchy, etc. File systems can also have several different types, the most common being ext2, ext3, ext4, and xfs. So you'll see here in this picture below, we see some files. We see the file system type. We see NTFS, VFAT, NTFS, swap, ext4 there. So we actually go back to our machine here. If you do a df-h and then capital T for type, it'll show you the type of file systems here, okay? So we see some different ones here, squashfs, tempfs, VFAT, but we do see the ext4 there. Okay, so this is the type of file system it is, okay? You don't have to worry too much right now about what types of file systems mean. Just be aware that there are different types of file systems, different formats. So in summary, we went over file system organization, file types, file and directory naming rules and conventions, commands for navigating the file system, introduction to inodes, ownership permissions and dates, manipulating files and links, manipulating directories, determining disk usage, and other file system utilities. Next session, we're going to be doing I/O, which is input, output, redirection, and pipes, command separation and grouping, background execution, file name expansion, shell variables, command substitutions, quoting and escaping meta characters, Z-shell features, fish shell features, command execution, startup files, and customizing the user environment. Again, guys, please, if you're struggling with any of these concepts and need just a little bit of extra help, please check out our private tutoring sessions for system administrators. We have weekly and monthly plans available, as well as Linux and Bash scripting private tutoring sessions. Just click on this link and follow it to the website. Thank you so much for joining me. I look forward to seeing you in our next session, and I hope you learned a lot today, guys. You're starting to feel a little bit more comfortable with this system.